Um, this shadow problem is the one from the homework, which I thought was, I remember when I first did it, I was really confused, but I just did it now and I got it done real quick. So I thought I'd share in case any of y'all are stuck on it. Because when I was first doing it, I was like, what the heck? I did it today and it was all okay. So this one is a lot trickier than the one on the homework. It's the Michael Jackson similar triangles problem from homework 22. And it's just a little different, but I think it's really hard to do when you don't really understand the how to do the one from the notes or the one that was on the quiz. So I'll explain it here if you need it. All right, so let me read this first. A spotlight is on the ground 21 feet away from a wall, and, and a 6 foot tall man is walking towards the wall at a rate of 2 feet per second, as shown in the figure to the right. How, why did I stutter 16 times? Fast is the height of the shadow changing when the man is 6 feet from the wall. So what we want to know is how fast this is changing. The height of this guy. This is the shadow, by the way. It's the guy. He's not like increasing in size. Um, but this is his shadow. And we want to know how fast is increasing as he's walking towards the thing. Okay. So what we're gonna do is the same thing as last time. We're gonna draw that little triangle and this big triangle and relate them. All right. So I'm going to draw the big triangle first. We know that this is 21 feet over here. The spotlight is 21 feet from the wall. And a 6 foot tall man is okay. We don't know this or the rate of change of it, so I'm going to label it height, 8 or H for height. I'm going to draw our tiny similar triangle. We know that the man is 6 feet tall. And we can figure out this length right here because we know that uh, the man is 6 feet from the wall. But this 6 feet value is like, which would make this 15. This is changing as he's walking. It's not a constant. So, like how we wouldn't want to just plug in a radius that we could like get from the from in a cone problem, we don't want to just put in 15 here because we're looking for the like we want it to be changing and not a constant. I'm going to label this X and then this 21 minus X, but it doesn't matter. This one can be whatever. So I'm going to call this X. All right. The next thing we're going to do is construct a relation between these two triangles, just like we would for the other problem. I'm going to say x over 6 is proportional to 21 over h because these are two similar triangles. From here, we can simplify. So cross multiply 21 times 6 is 126. It's equal to x times h. From here, we want to take the derivative, which this is just 0 because it's a constant. But then we need to do product rule for x times h because these are two variables. So I'm going to take this over here. H, and then oop, our the derivative of x is 1, and then we add our, oh, d8, whoops, hold on, sorry, our dx over dt, and then same dealio for h over here. And then from this, we can do normal product rule, so h times dx over dt plus times dh over dt. And from here, what we're looking for is the dh over dt because we're trying to find the change in h, the shadow changes. So we want to keep that as our thing, but we can plug in the rest of these numbers here. We do not know we do not know h, but we can find it in a second because we can find x. 21 minus x is equal to 6 because the man is 6 feet from the wall, right? So 21 minus x equals 6. And then this would be -15, I think. Yeah, 15. So x should be 15 feet. Now that we have x, we can find h because if we're saying that x equals 15, we can go back to our original formula here to determine what h is equal to. So it'd be 15 over 6 equal to 21 over h. And then we can do the exact same thing. 126 equals 15 times h. 126 divided by 15. I'm going to plug that in real quick. Oop, ignore all that. 126 divided by 15 is equal to 8.4. 8.4 feet. Feet. So now we know h, we know x, and we already knew dx over dt because it tells us here that the 6-foot tall man is walking towards the wall at a rate of 2 feet per second. So this right here is increasing at a rate of 2 feet per second as he's walking across the wall. So 0 equals, let's plug in our h, 8.4. dx over dt it was 2, right? Yeah, 2. And it's increasing, so it's positive, which was 15 dh over dt. Now we can just isolate our dh over dt to further simplify to get this all done. 8.4 times 2, 15. Negative 8.4 times 2, 15. Fraction form is 28 over 25, negative 28 over 25. So we know that dh over dt is equal to negative 28 over 25 feet per second. Yes, feet per second. All right, so that's our answer for that. Now to move on to the angle of elevation. The angle of elevation, if you remember from pre-cal, is just this right here. The angle elevated. But also it's kind of obvious because they literally give you the little line here up to Michael Jackson's chat. So too hard there. Anyway, we're looking for how fast the angle of elevation is changing. So we're looking for d theta over dt. So we're trying to determine. And so a way that we can find theta is through using our trigonometric functions. And so we know h and we know 21. So we can use the trig the whatchamacallit, the trig function that relates the angle that is opposite and the angle that is adjacent, which is tangent. So tangent theta is equal to opposite, so h over 21. And we don't want to plug in h here because 21 is going to be constant, but h is changing. So the same reason we made this x, we're going to keep this as h. Because while we know it at this instant, we want to we want to use it to find our derivative. So anyway, now we can take the derivative of this. So secant squared theta times d theta over dt. That is the derivative of tangent times 121 dh over dt. Because this would be like 121 times h, basically. 1/21ths. I don't know. How do you say that? I have no idea. Um, so this would just disappear because because it's not squared or anything. You're multiplying it by. Um, Now we have that. So the most pain in the butt thing you got to do here is find the secant squared of theta, which We can find out what theta is through just doing, let me do it over here, just doing tangent. So like tan of theta is equal to, and we know we can plug in because we're looking for at the instant now, and we've already taken the derivative. So when we're finding it, the angle now, we can plug in what that h value is, which is 8.4, and then divide it by 21, and then theta is equal to the inverse tan 8.4 over 21. And then because we get calculators, I would just plug this in to secant squared of theta right there. Let me do that real quick. So secant the inverse tangent of 8.4 over 21 squared is 1.16. So 1.16 times d theta over dt equals 121. And then dh over dt, we know from the previous problem, it's negative 28 over 25. And then from here, we can just isolate our d theta over dt. So d theta over dt is equal to 121 times negative 28 over 25 divided by 1.16, which is negative 0.046. And that would be radians per second. There you go. Mm.